Hi everyone, I'm Jeff. I'm here to do an unboxing for a product that I got on Kickstarter. It was a while back, it was almost a year ago, and I just received it in the early shipment for the beta release of the board. It's from a company called Particle, and the product is called the Tachyon, and it's basically all the components and power that you would expect in a cell phone, a mobile phone, in the form of a Raspberry Pi. And I'm going to go through the components, and I'll talk a lot more about the Tachyon device itself. So let me switch over to my desktop so you can see. So we'll start with, first of all, here's the box for the Tachyon. Hold on to that, and that'll be the last thing I pull out and talk about. The first item is the USB-C power adapter. It also comes with a few quick, like quick switch plugs for different countries. Then I also got a GNSS antenna for the board. It also came with an audio board, which I think I think it comes with the device by default, I believe, but I'm not 100% sure. I also added on an NVMe base expansion board. This is by Ampironi. And then I also added on a 3-cell LiPo battery. This is 9300 a milliamp hour. And now for the Tachyon itself, they also include it, and I assume that's going forward, but I'm not positive. On a single cell LiPo, it's 1000. And the board itself, so this is the Tachyon board. Good close up of that. And you'll notice it's configured slightly differently. It doesn't have all the ports because it has so much compacted into it or put on it that they wanted to keep it in the form factor of the Raspberry Pi is the way I understand it. And I actually appreciate that because there are certain ports that I don't really need in an IoT environment, right? Not that they're necessarily bad for a development board, but I feel like this gets me closer to a production board, if not there already. If we compare this with the Raspberry Pi 5 that I have, or one of them, right? Look at the Tachyon is slightly shorter, just by maybe a quarter of an inch. It's a complete guess, but if I stack them on top of each other, right, basically the same width, being a little bit shorter, and a lot of the same components except for the Raspberry Pi, if I want to do any sort of AI inference, I have to use the AI kit and add that on. And then if I want this to connect to on the cell network, I need another hat or expansion board or some other form to get me that. So all of that is included in the Tachyon. The Tachyon is built on the Qualcomm Dragonwing line of devices that is targeted towards industrial and IoT applications. And there may be some other applications besides that. I believe based on what was said at Spectra, at the Spectra event last year, in the last year. But this is from the Q5 series of that line. So it has obviously a CPU, it's got a GPU and an NPU that is, I want to say, 10 or 12 tops. Um, let's see, it's got the standard header that you would see on a Raspberry Pi and the 40 pin. It's got a debug connector, UART. It's got the SparkFun quick connector, and which also supports um, the Adafruit um, stemma QT. That's I2C. It has the, on the CSI, DSI connector, and another CSI only connector. It's got a the connector for the LiPo battery. It has another connector for RTC or coin-based battery. It's got a USB-C connector that's 2.0 and a USB-C that is on 3.2 for both data and power delivery. So you can connect this to a USB hub that provides a display, and Ethernet, and a bunch of other ports. It has a PCIe connector. So if I was going to connect the expansion board for the NVMe support, I would do it through that. It has a slot for an SD card. That's for additional storage. This comes with 128 gigs of UFS. It also has secure boot and encrypted file system. I believe by default, the OS is already installed. It's a customized version of Ubuntu that is customized and managed by Qualcomm and Particle, I think, in partnership. And it supports, I think, I think the default install, at least based on the video I saw, is headless. But it also supports the full version of the desktop. So if you have a monitor, let me see what. Oh, it also because it supports connection to a cell network, which I think is also there by default. You're already on a cell network. As soon as you turn it on, you power it up. It has what they have termed EtherSIM Plus, which is their version of eSIM. It's one of their products that supports having more than one profile, and it will automatically switch between the profiles to try and get you the best connection, depending on the area that you're in, and obviously the various cell towers. If they also, by default, you get 2 gigabytes of data transfer over the network each month. The idea is to use that when you're prototyping, and then if you need more, they are coming up with plans for larger volumes of data transfer, and I believe the plan is also for one that is unlimited. I'm curious to see how much that will cost and how long before that's available, assuming nothing changes. On the backside, it lists the device ID and the IMEI numbers, and this plate is used to spread heat, so for a little bit of management thermal-wise, but there's also some software going on, I assume some drivers and firmware that are also going to be managing the thermal footprint, and it'll throttle the speed of the processors to try and keep within a certain tolerance of heat to try and minimize that. I mean, there's so much to talk about, right? Like You can, because there's an AI accelerator, you can do, you can go and load some of the models, whether it's for vision or whatever it is, ones that can be done on a small device like this, and do the inference locally. And let me switch to my desktop. Turn off my desktop. Turn on. I'm trying to think of what else. There's quite a lot going on here, and I talk a lot more about it in the post on the blog that I'll have in the description. A lot more information and kind of a discussion on my appreciation of the design and the thought that went into this. The other thing that I'll mention is you can see the space that was taken up where the other ports are on the Raspberry Pi. That's where the Wi-Fi antennas and the cell antennas are for the device. And I believe this is still true. I don't think it was what was said at Spectra last year. I think it was an AMA and kind of like a discussion that talked about the architecture. And I believe, hopefully I'm not wrong on this, that the enclosure on top of the antennas acts as a booster. So try and spread out that signal and improve it. So I find that quite intriguing. And I'm sure there's a lot more I could discuss on this. Oh, the one thing I will show you, don't at this point, I can't remember if I talked about the SD card. There is an SD card slot. And so if you want to, I think I did mention it, but let's pop an SD card in. Pop that card in. So I need my face in front of it so it doesn't blur my background. I'm getting a lot better at putting the SD card in. Because I'm used to the regular Pi, right? And if you've already installed the device, it becomes a little difficult even on the Raspberry Pi for me. But so I think that's at least the highlights at the very least. And hopefully this has been helpful, and hopefully you'll go and check out more, whether it's on the actual product site or on the blog post. And I will talk to you later in other videos. Thanks. Take care.